Today I will introduce you all types of electrical motors. Quick and easy. Hi, my name is Markus and hello together here from Berlin. As a consultant for electrical drives in the automotive industry, I'm often being asked what alternatives there are to permanent magnet synchronous motors. That is why I'm introducing you all types of electrical motors and the differences between induction motors and synchronous motors with and without magnets. Electrical motors can be divided into DC motors and AC motors. Since AC motors do not require mechanical commutators, they have a much longer lifetime compared to DC motors. This is why AC motors are primarily used for electrical vehicles, and they also have a higher power density and a higher efficiency. Therefore, we want to take a closer look at AC motors today, which can be divided into synchronous motors and induction motors. Induction motors are also often called asynchronous motors and are shortened with ASM or IM. They can be divided into two different types, one with slip ring rotor and one with squirrel cage rotor. The slip ring rotor has windings which are connected to the slip rings. The squirrel cage rotor only consists of a short circuit cage and does not require slip rings. This motor type is therefore more robust, cheaper and more common. In an induction motor, the rotor runs slower than the rotating field of the stator. In other words, the rotor runs asynchronous to the magnetic field of the stator. The speed difference inducts a voltage in the squirrel cage, which results in a magnetic field of the rotor. With the right control strategy, induction motors can today achieve similar high efficiencies as motors with permanent magnets. They are very robust against high temperatures and cost-effective in the production. Synchronous motors can be divided into three different types: reluctance motors, permanent magnet synchronous motors, and separately exceeded synchronous motors. In a synchronous motor, the rotor rotates at the same speed as the rotating field from the stator, which is generated via the windings. In other words, the rotor rotates synchronously with the magnetic field of the stator. Permanent magnet synchronous motors, or PMSM, can be differentiated into IPMSM and SPMSM. The two types differ primarily in the design of the rotor. The stator is the same for both. In an SPMSM, the magnets are attached to the outside of the rotor surface. The S stands for surface, so the motor is called a surface permanent magnet synchronous motor. In an IPMSM, the shortcut stands for interior permanent magnet synchronous motor. The magnets of this motor are embedded in the rotor. Permanent magnet synchronous motors are very efficient and are characterized by a high power density. Due to the magnets in the rotor is a PMSM a very powerful but expensive type of electric motor. Instead of magnets, externally exceeded or electrical exceeded synchronous motors have coils in the rotor, which generate a magnetic field depending on the current flowing in the coils. Synchronous motors with external excitation are shortened with EESM or SESM. The shortcut SESM stands for separately exceeded synchronous motor. The main disadvantage of externally exceeded synchronous motors are the slip rings, which transmit a DC current to the rotating rotor. The slip rings and the windings on the rotor also limiting the maximum speed of the motor type. One of the biggest advantages of SEM-SM is that the strength of the magnetic field of the rotor can be adjusted over the DC current. Therefore, no additional stator current is required to weaken magnets, as it is necessary with a PMSM to achieve high speeds. The third type of synchronous motors are reluctance motors. They can be divided into switched reluctance motors and synchronous reluctance motors. Especially for reluctance motors, we have made a video which explains the detailed differences and why the inverter is more expensive for some reluctance motors. You can find the link to the video in the description and please subscribe to our YouTube channel to support us. The main advantage of reluctance motors is that they have no magnets or windings in the rotor and are therefore very inexpensive. A disadvantage is that you need a very small air gap between the rotor and the starter to have a good efficiency. The power density is also lower compared to motors with permanent magnets. Here once again the complete overview of all types of electrical motors. As we have seen, most motor types differ primarily in the design of the rotor,